The lesson for today is surface area of prisms and cylinders. And the objective of this lesson is to find the surface area of triangular and rectangular prisms and circular cylinders. Uh, let's take a look at this scenario. Maria was buying stamps at the U.S. Post Office when she noticed shipping boxes on display. Price list as shown at the right. Maria wondered if the price of each box was related to the amount of the material needed to make the box. Is the ratio of the price material about the same for each box? And you will solve this in exercise 27. The reason why we're showing this example is because if you take a look at this one, you have three types of boxes with different dimensions, okay, and they have different prices as well. And we want to find out if the size of the box has something to do with the amount of material needed to make that box. Okay, so by looking at the surface area of each box, we can determine uh, how much material is needed to make these particular boxes. Okay, and we'll revisit that on exercise 27. But before we do that, let's learn some new concepts. And in geometry, solids like shipping box shown above are called prisms. A prism is a solid figure that has two parallel congruent sides called bases. Okay? A prism is named by its shape of its bases. The shipping box uh, and the prism shown to the right are called rectangular prisms. Okay, so this is a rectangular prism. Why is it called a rectangular prism? Because it has two bases which are rectangles. Okay, so this is a rectangle right there. Okay, and there's another rectangle underneath, which are also called the bases of this particular prism. Okay, a more precise definition of a prism is a solid whose bases and ends are similar, equal, and parallel plane figures and whose sides are parallelograms. If you notice, the top and the bottom are both rectangles and they're both parallel to each other. And the sides are also shaped like parallelograms. Okay? So aside from having bases which are parallel to each other and at the same time congruent, okay, the sides are also called the sides of a prism are also parallelograms. Okay, this is what we call a triangular prism. Okay, because it has a triangle as its base. So it has two triangles as its bases, and that's why this is called a triangular prism. If you also notice, it has sides that are parallelograms. In this case, they are rectangles. Few more definitions. Another definition that we need to look at is what we call surface area. The amount of material that it would take to cover a geometric solid is called surface area. Okay, if you open up or unfold the prism, the net result or the result is a net. Net help help us see the regions or faces that make up the surface of a prism. The surface of a prism is the area of the net. Let's take a look at the triangular prism which we discussed. I discussed a few seconds ago. And if I open up this particular prism, it's going to look something like this. This is now the net of my triangular prism, where you see these are the bases, and this is the back, the bottom, and the front of the prism. In the same manner, now let's take a look at the same rectangular prism we just talked about. Okay, and this rectangular prism, if I open it up, will look something like this. Okay, we'll have a top, bottom, front, back, and two sides. If you also notice, it does not label the bases because rectangular uh, each of the rectangles that are congruent to each other can be considered the bases. The back and the front, Okay, the top and the bottom, or the two sides, can be considered the basis of the rectangular prism. And this rectangular prism has 6 faces. Let's take a look at this one and see how they really look like. Okay, this is a triangular prism, and if the triangular prism opens up, this is how the net will look like. Okay, and this is an example of a rectangular prism. And if I create a net of my rectangular prism, this is what it looks like. And a rectangular prism will have 6 faces, and it will have 8 vertices and 12 edges. Okay, going back to my triangular prism, it will have 5 faces, 6 vertices, and 9 edges. Let's define what surface area is. The surface area of a polyhedron is equal to the sum of the area of all its sides, of all its faces. And said another way, the surface area is the total area covered by the net of a polyhedron. Now, okay, a polyhedron is nothing more than let me find that one. There it is. So a polyhedron is nothing more than the solid bounded by polygons or the flat faces. Okay, it is a solid bounded by polygons or flat faces. So it's a three-dimensional figure wherein all its faces are flat. Okay, just like a triangular prism or rectangular prism. That is a polyhedron. Okay, let's go to the first example. Find the surface area of a box that measures 15 inch by 10 inch by 12 inch. Okay, and method 1, sketch the box, and this is how the box looks like: 12 inch by 15 inch by 10 inch. And we will use the formula length times width to find the areas of the faces. Why length times width? Because the faces are all rectangles. Okay, the front and the back of the box. Okay, the front and the back, these two, has a length of 12 inches and a width of 15 inches. Why is it multiplied by 2? Because there are 2 of them, the front and the back. Top and the bottom again measures 10 inch by 15 inch. 10 inch by 15 inch, so we're looking at this area of the box, which is 300. And the two sides measure, okay, 12 by 10. So 12 by 10 will be these two rectangles, that rectangle and this rectangle on the other side. So basically, when you talk about the sides, this is what's looking at. Right there and right there. Those are the two sides. And if you add up all the areas of the two sides, it equals 240. All we need to do now is add all the areas of all the surfaces. 360 plus 300 plus 240 will give us 900 square inches. So the total surface area of this box is 900 square inches. Method 2 is similar, but instead of looking at it in a three-dimensional figure, we create a net for our box. And this is how the net of our box would look like. And we label the dimensions of the length and the width of each of the faces. Okay, and this is what we get. We get the area of the bottom, which is 150. The area of the top is the same thing, 150. Sides, back, and front. After that, we add the total areas of all the faces of that box, which still end up as 900 square inches. Okay. To make it easier, I have given you the formula for a surface area of a rectangular prism. the surface area of a rectangular prism is 2 times the quantity length times width plus length times height plus width times height. Okay? And the surface area of a cube, which is very similar to a rectangular prism, the only difference is that the cube has sides that are all congruent. That means the length, the width, and the height of a cube are all congruent. That's why it's just labeled as S. Okay, so the surface area of the cube is 6S squared. Now applying those formulas, okay, we have our box, and we want to find the surface area of our box using the formula length times width times height. Okay, and let me get my board here. Okay, so let me get my screen here on. So the surface area formula is equal to 2 times length times width plus length times height plus width times height. And if we apply that formula, we now have 2 times, put this on the side so I know where my numbers are. There you go. Okay, 2 times 12 times 15 plus 12 times 10 plus 15 times 10. Simplifying what's in the parentheses, okay, 12 times 10 is 120. 15 times 10 is 150. 12 times 15 is 110, 170. Okay, so this becomes 2 times 170 plus 120 is 290 plus 150 is 300, 440, 450. Because that is 180. Let me correct myself there. This is 180 and this is 450. Okay, so the surface area of my cube or of my rectangular prism will be 900 square inches. The unit is very important. Don't write down the unit, okay, your answer will be wrong. Next one, let's look at our cube, which has a side of 5 feet. Look at our cube, which has a side of 5 feet. Okay, that means to find the surface area of my cube, which is equal to 6s squared, and s is equal to 5. All we need to do is get 6 times 5 squared, or 6 times 25. And 6 times 25 is 150 square feet. Okay, so by using the formula, we can find the surface area of both our cube and our rectangular prism. Okay. Okay, moving on. Let's find the surface area of a triangular prism shown on the right side. So this is our triangular prism. The only reason why it's called a triangular prism again is because the bases are triangles, two congruent triangles. So we want to